So we've looked at plotting points in three space. We've looked at plotting ordered triples. But now let's think about what would surfaces look like. In other words, what would happen if we put some of these points together? What would their graphs look like in three space? Well, to begin with, think back at your journey through mathematics and how when you first started out just thinking in one dimensions, where you had the number line. And let's suppose you were asked to find, let's say x equals 2. Let's suppose that number line, we'll call it the x-axis. If you were asked to find x equals 2, that would have just been 1 point right there. See, if this red is the x-axis, this would have just been a point. But then you added a dimension to it. You said, okay, well, let's look at the x and the y-axis. So now the green is the y-axis, and now we interpret x equals 2 differently. In that context, we have x equals 2, and that means no matter what y is, x is always equal to 2. So if y is equal to 2, x is 2. If y is equal to 4, x is equal to 2. So what it amounted to was a vertical line. But let's go another dimension and say, well, what if we have not just the x-axis and the y-axis? Let's suppose that we have the z-axis. So think about what that would be. You have this line, and then let's get to where we can see the z-axis. There it is. There's the z-axis, this blue axis. And you'll notice what happens is we have the line down here on the xy plane, but then that line is extended up for various values for z, for all the values for z. So what you get here is you get a plane. So this is something different. So now when we start off, x equals 2 was a point. When we added the y-axis, x equals 2 was a line. Now when we add the z-axis, x equals 2 is a plane. Now the two surfaces you're probably very familiar with are the sphere and the plane like we just looked at. But what we want to do is branch off and look at some other types. For example, the cylinder. And you might think, well, I'm already familiar with the cylinder. This is probably the type of cylinder you're familiar with. This is a cylinder that is, we have this equation x squared plus y squared equals 9. You notice this has a radius of 3. This would be the equation if we're in 3 space to describe that cylinder, that right circular cylinder. Notice notice if we're on the plane, if we're in the xy plane, this would just be a circle. So if we're talking about just being in the plane, it would look like this. It would just be, this is us looking from above down at the XY plane. This is what that cylinder would look like, okay? Now notice, this is just a curve down here in the XY plane. This curve, in the context of talking about cylinders, we refer to as the generating curve, okay? So cylinders are going to have generating curves like this one does. And this particular generating curve is a cylinder. And this particular one is in the XY plane. Generating curves don't have to be in the XY plane. We're just looking at this one as an introduction, okay, to help us to understand what a cylinder is. So this is the generating curve. It's like when z is equal to 0. Now, think about this. Think about lines that are extending from this XY plane, and these lines are not in a parallel plane. In other words, these lines do not lie in a plane that's parallel to the XY axis, the XY plane, okay? So there are lines coming out. Now, you can see here on the picture, these lines. These are the lines I'm talking about. These are lines that, in this case, they're perpendicular to the XY plane, okay? Now, all of these lines are parallel to each other. So think about all of these lines that are passing through this curve, this generating curve, going out into the z direction. Think about all those lines that are parallel to each other. Okay. In this case, all those lines are going to be parallel to the z-axis. But think about the union of all of those lines. Those lines are called rulings. Rulings. In this case, we have the generating curve is in the xy plane, and the rulings are parallel to the z-axis. Whenever we're talking about cylinders, that's what we need. We need a generating curve in a plane. We need rulings that are not in the plane, a plane parallel to wherever the generating curve is. The union of all those rulings, like in the case of this one is a cylinder. Okay, now let's look at some other examples of cylinders that might broaden our horizon when it comes to thinking about cylinders besides just the right circular cylinder. Let's think of some others. So let's think of this one. Let's think of y equals sine x. Now you might say, that's not a cylinder, that's just y equals sine x. Remember, we're in 3 dimensions here. So yeah, on the xy plane, if you're just in the xy plane, this looks like this. Okay? There's 0 to 2 pi. That's what that graph looks like. But think about what this would look like if you tilted the axis a little bit. Let's take a look at that. Okay, so here's the graph y equals sine x. Now, think about you're looking down at this. You're on top, you're up here on the z-axis looking down. Let's rotate this over a little bit. There we go. Look at that. I rotate it over a little bit. Now we can clearly see the z-axis part of it, right? Think about this is coming out. The green is the z-axis. See, the green is the z-axis. Okay. Now, this is a cylinder because notice what we've got. Let's just think about the parts of this, and let's see how it fits the definition of a cylinder. Notice that we've got the generating curve, right? We've got these generating curves. Look at this. Okay. Now, and you can see them here. Look at all these curves. See those curves right there. As you change the value of z, you get a brand new sine graph, right? Y equals sine x. For the various values for z, it starts making this little surface. Now, look at these rulings. See the rulings, okay? See those? Those are the rulings. And you can see them here, okay? See all of those. So y equals sine x is definitely a cylinder. It's got the generating curve. You've got this curve that's in the plane. Let me see if there it goes. It's rough. Okay. So you've got this curve in the plane, the generating curve, and then you've got those rulings coming out. Okay. Like that. So that's the y equals sine x. And those rulings, think about this now. What are those rulings parallel to? Think about it. See? Look at those rulings. They're parallel to the z-axis. So y equals sine x will give you a cylinder, the rulings of which are parallel to the z-axis. Okay? And you can see that if you play around with this. Notice the green here, that's the z-axis. And look at these rulings. See those? Those rulings, parallel to the z-axis. Okay, let's think about another one. Let's look at z equals y squared. Now notice here is the y-axis down here. Here's the z-axis. And z equals y squared would just be a parabola. Okay. Now, if you were thinking about, if you're just looking at it this way, we're most commonly we would say y equals x squared, where this would be the y-axis and this would be the x-axis. But it doesn't have to be that way. Here is z equals y squared, and you notice z is a function over here of y. You put in a y, you get out a value for z. But now, if we're in three dimensions, this is not just a parabola, this is a cylinder. So we can see that by rotating it a little bit. Ah, there it is. Now notice the red axis here. That's uh, that's what we didn't see earlier. See, this is uh, z equals y squared. Now we can see that, okay, this thing goes along the y-axis. So if you think about, so you see the generating curve is just this parabola. Okay, there it goes. That's the parabola, but it also has rulings. Now think about which what the rulings would be parallel to. Think about what they would be parallel to. Think about rulings going down through here. Can you tell? I'm not showing the rulings here, but can you tell what the rulings would be parallel to? They would be parallel to the x-axis. So dig this. Z equals y squared is this cylinder with the rulings parallel to the x-axis. Notice you could think of it, the x is not shown here. That's precisely what the rulings are parallel to.